Hello, everyone. Let's get started. It's 10:04, and I think it's time to get started. Guys, thank you so much for joining today. I know it's a Saturday, and for many of you guys, it's probably a Saturday evening. But you have taken the time to join us and learn a few things from us. And I promise we won't disappoint. Again, thank you so much for joining. Before I introduce myself, I see a lot of people have joined. So why don't you go ahead and introduce yourself? We already see your name, but why don't you just say where are you from and what you do right now? You can just type it in the chat, and I'll read it aloud. We have Keval Bhatt from India. Who else? So we have Anand, we have VK, Hari, we have Ed from NYC, we have Leonard from Dallas, Texas, Umar from NJ, great. We have Manasa, we have people from Bay Area, Nathan from New Delhi, Praveen from India. Canada, we have a person from Canada. Karthik is from Toronto, Canada. Perfect. So we have people from India, so far US and Canada. A lot of people from California. Great. Let me introduce myself. My name is Patrick. I'm one of the lead instructors and course creators at HadoopInRealWorld.com. Right? The story of Hadoop in Real World. We started. It all started back in 2008. That's right, 2008, and we had a group of big data consultants working for one of our banking clients, right? And one of the big boss in the banking in the company, came to us and said, we have this problem, a long-standing problem in our data warehousing teams, where there are a few ETL jobs which runs for hours. Right? And this is creating a lot of problem for us. And he asked us to, get a solution, solve the problem. So basically, what he's asking us to do is optimize the slow-running ETL process, the solution that we currently have. So we went out, we were looking for, solutions like how to solve it. Can we optimize the query? Or, can we do something else, or can we break the files apart, add more indexes, whatever, right? So we were doing all that, and we came across a new technology at that time, 2008, right? At that time, we came across a new technology, this brand new technology named Hadoop. Okay, so we looked at it. We tried to understand what it was, because at that time, there were not a lot of well documentation or a lot of online help as you may find right now, So there were a few pieces here and there. We did a POC in a couple months, and off we go. In a couple months we had a small little cluster working, and we were able to optimize the ETL process. And a process that was running for 2.5 hours, we were able to get it done in like 20 minutes. That is a very first success story for us with respect to Hadoop. Right? Then the challenge came in, which is how do you find qualified, Hadoop engineers to work on our projects, right? And that was a constant problem for us at that time, because Hadoop was not as widely popular as it is right now. So, we were trying to find qualified Hadoop engineers, but we couldn't find any, right? So we put together a training program. So what we would do is we would hire some qualified developers or programmers, testers, whatever role we are trying to fill. We will hire that appropriate person, and then we will train them on Hadoop, right? And our training is like, it's not like a textbook training. You don't read it from a textbook because it's pointless for us, right? We wanted to show them how Hadoop is used in real world. Right? You get the name, you get our name, Hadoop in Real World, right? So we wanted to show them right away how Hadoop is used in real world, what are the problems we are facing, and how are we solving the problem. So we would teach the concepts, we teach the problems, and we would teach the solutions to them, right? And we don't have a lot of time. We can put them on like a month-long training. We would ask them to train. We'll do a quick training for them, and then we will get started right away. Okay, so that's how it started. And you know, the training that we had was so good, was so practical. You know, there were a couple of other companies reaching out to us to do the same because we were doing consulting at the time, right? And we still do. So other companies came to us and said, like, can you train our folks? We have the same problem. We cannot find Hadoop engineers. Can you train our personnel to do this? So we did that. You know, we would go in, but we would, consulting was our full-time gig. So, you know, we would, when we find time, we would go and train other people, right? So now, a couple years later, the training was taking a lot of time for us, so we bundled it. You know, we packaged it, so to speak, right? And you know, we made it online inside the company, inside those companies, right? We made it online. And then 2012 to 2015, we did a lot of workshop kind of sessions as well, you know, out in Chicago. We are primarily based out of Chicago, so we did a lot of sessions in Chicago, right? And then 2015, we came out with our first online course because we saw the demand was nice. The demand was very good, actually. And the students who were going through our courses, you know, found a great benefit because we were not teaching like textbook style or reading a textbook or, you know, we were not teaching like word count problems, right? We were teaching like real problems, real solutions, how to address them, optimization, troubleshooting, real skills that you would need for your day-to-day job, right? So we went online, and fast forward 2015, I said, you know, we went online with our courses, and fast forward now, we have about 65,000 students. We have I shouldn't say about, we have over 65,000 students in all our courses combined, right? So I have so many people right now in the audience. How many of you guys have been or you know, are students in one of our courses? Can you just chat with us and say like, wow. Okay, so we have Keval, Anand, Tirumala, Leonard, Niraj. Perfect. Great. So we have Ed, Shashank. So lot of guys, lot of people. Have Meenakshi saying, big fan, excellent. Thank you. Anyone who doesn't know about us, who's just knowing about us, anyone who's not a member or is not a student of our courses? Okay, so we have people, I'm new here. Nitin is saying I'm new here. So a lot of people are new too, so that's good. Some people read my blog very first time. Malik Arjun is very first time. Bhima, very first time. Perfect, guys, perfect. That's awesome. You guys are in the right place. I have to tell you, you guys are in the right place. Okay, so just for those who doesn't know, we have 4 courses now, okay? So we have Hadoop Developer in Real World, Hadoop Administrator in Real World. These 2 are full-fledged developer and admin courses. These are separate courses, for one for developer and one for administrator. We have two other courses as well, Hadoop Starter Kit, that's our very first course, and our most recent course is Spark Starter Kit. Okay, so Hadoop Starter Kit and Spark Starter Kit are more for beginners, and if you're very new to Hadoop or Spark, that's a great course. But on both those courses are free, right? And if you want to dive in depth, Hadoop Developer in Real World and Hadoop Administrator in Real World are the courses for you. Okay, so great. So we have 65,000 plus students. That is great. But are they happy? You know, from the looking at the chat, I can clearly say we are happy. But just for you guys who are very new to us, yes, we have very happy students. And this is one of the review from one of our students. And guys, anytime we receive a review or we receive a feedback, we love it, right? We love our students. We always say that. But anytime when you guys come back to us and say like, give us feedback, give us even a positive feedback or even a critic, we love it. You know, we love to hear from you. So here is a feedback from one of our students. Very clear explanation of concepts. And of course, this student is talking about the course. Structure of the content is very logical and flows naturally. I found concepts covered here like high partitions, bucketing, flume multiplexing, etc., combined with real-world examples. I've looked at few other courses, and these concepts are not covered anywhere else. It is one of the best Hadoop courses that I have come across. And feedback like this, you know, still gives us chills. You know, we love We'd love to hear from you guys. And if you have any feedback, even a positive one or even a critic, write us. info@hadoopinrealworld.com. We would love to hear from you. Okay. So now, all good. So you know our story. You know the courses we have. I spoke about an introduction. So let's talk about today's agenda, right? I'm not here to talk about just courses and about us. You're here spending your Saturday, at least an hour of Saturday with us. So, it has to be worthwhile for you. So what are we going to teach you today in this hour? We're going to talk about two file formats in Hadoop. Two very successful file formats, or very popular file formats, I should say, in Hadoop. RCFile and ORC, or known as ARC. Okay. So if you're new to Hadoop, some concepts that I'm going to say here might be a little overwhelming for you. But hang tight, okay? I'll make sure that you're not completely lost, but you will for sure grasp the concept that I'm going to talk about here today, okay? So do not worry if you understand few concepts. It's just because you're new to the technology and nothing else, okay? And RCFile and ARC, these two concepts, we recently updated our Hadoop Developer in Real World course. Actually, we update our course regularly, and RCFile and ORC file lessons we added just recently. I think it was like last month, like a few weeks back. Okay, so you're looking at brand new content from one of our courses. All right, perfect. So here is a table. Let's just imagine this is a table, right? It's a table from a stocks data set. So we have day-to-day stock-related information from NYSE, New York Stock Exchange. Okay, so we have the symbol, we have the exchange name as the first column, symbol next, the dates, and we have these numbers are basically the opening price, closing price, the high, the low, and the volume right here. So this column right here that you see, it's volume. The second column from the last is the volume, right? And then you have, I think it's the average close. So this is a traditional table, right? It's a row by row table structure. This is how when we query, like, for example, when we run a SQL against MySQL or SQL Server or Oracle, this is how we see the data. And this is how our mind is trained to visualize or look at data, right? We love row by row formats, right? We love row by row formats because that's how we are trained. That's why Excel, we have like row and columns, right? It's very easy for us to see. But is it efficient from the computer standpoint? From the system standpoint, is it efficient to have our data in this structure right here? Okay, let's take a look, right? So my query here is select star from stocks, all right? And assume we're doing a query against like MySQL or SQL Server or Oracle. Let's not even talk Hadoop. Okay, we're just learning some basic concepts here. So when I say select star from stocks, the database will go through the record, like this. For the records will be laid in the disk as you see here, right? So row number 1 will be laid in the disk first. I'm talking about how this is stored in the disk, right? So record number 1 will be first laid out, followed by record number 2, followed by record number 3. When I say record number 3, I'm talking about all columns. First column 1, column 2, column 3, for record number 1, so on and so forth, right? So when we say select star from stocks, you're reading like this. Your disk will start reading from the first column, will continue to read all the columns, then move on to the second row, first column, so on and so forth. It's efficient actually if you think about it, because your records are laid sequentially on the disk, right? So whenever you read sequentially, whenever you go from one point to the other without jumping, like when you go sequentially, you're efficient. Your reading is much efficient. Okay, so select star from stocks is going to give you an optimum result, no problem. And this format of data that we see here is called row major. In general sense, it's called a row major format because we are seeing the data row by row, or more importantly, we are storing the data on the disk row by row, one row after the other, sequentially, okay? Now, same table, I'm asking you to get select volume from stocks, right? And this is going to be difficult. When I say select volume from stocks, why this is going to be difficult? It is not difficult. It's not very efficient, okay? It's not very efficient. Why it's not efficient? Watch this, right? I said the data on the disk is stored row by row, sequentially, right? So to read the volume column, so you have to traverse through all the columns. You have to ignore them, right? Because we're not interested in exchange. We're not interested in the symbol. We're not interested in the date. So you have to skip all these columns and go to the volume column, right? Then you have to do the same thing for row 2. Then you have to do the same thing for row 3, right? So you're reading and skipping a lot of unwanted columns to reach volume. And it's almost at the very end, right? And this you have to do for every single row in your table. Now, let's think of a big data set, okay? When I say big data set, like visualize like 1 terabyte or 2 terabyte file, with the same content, right? With this content in this specific format. And you're scanning your 2 terabyte file, for instance, doing a scan like this, it's going to be highly inefficient. Even for Hadoop it is, right? And if you know Hadoop, Hadoop is going to distribute the load, all well and good. Your file will be divided into blocks. Still not efficient, guys, right? If this is a text file with 2 terabytes and you're reading and skipping columns just to reach the column at the very end, for each row, it's not efficient at all, okay? The other problem with this thing is compression sucks when you have data like this, okay? Because you cannot do, the compression is always better when you have like elements, when the elements are alike, okay? When you have strings grouped together, you can compress it nicely, okay? When you have numbers grouped together, you can apply efficient compression when you have numbers grouped together, when you have strings grouped together. And you can see here the data types of these columns are all different. You have string, you have a date, and then you have a number, like a floating digits, right? So the data types of these columns are like jumbled. They're not grouped together. So compression, from the compression standpoint, you're not going to get efficient compression. Okay. So this is row major format. So going back one slide, it is great in a row major format if you do select star from stocks. The row major format will do just great. But if you are doing column-specific operations, it's not that good. It's inefficient. I shouldn't say it sucks, but it's inefficient. And same from the storage standpoint, from the size of the data set standpoint, right? Your compression is also very inefficient because you're not storing the same kind of columns together. Okay. So those are the issues with row major format, all right? And now think about it. If you're doing a lot of data analysis, you're most likely doing select average of volume from stocks. You're doing a lot of column-specific operations. That's what you usually do. You do column-specific operation. How often do you do select star from stocks? Sometimes you do. Yeah, sure. But a lot of times you're targeting columns. You're grouping. You're doing a lot of grouping. You're doing a lot of aggregation. You're applying analytics on the columns themselves. Right? So row major, even though it works for entire rows, doesn't usually work for selective columns. Okay? So now visualize this. This is storing everything in a columnar way, meaning all the column 1, the column 1 from all records are stored together. Okay, the same data set, the same data. We're looking at the same data, guys, right? But it is stored in columnar fashion, right? So column 1 values are stored together from all rows are stored together. Column 2, that is the symbol column, is stored together. The date column is stored together. And imagine this is how it is stored on the disk, okay? This is how it is stored on the disk. It's a little bit of a mind shift if you're new or if you're hearing columnar data format for the very first time. It is a very old concept, okay? It's not a new concept, but it is okay if you're hearing this concept for the very first time. It might take a little bit of time to adjust, okay? But it is okay. It is totally fine, right? So, we are storing exchange, that is column 1 from all rows together, column 2, that is symbol column from all rows together, date column, that is column 3 from all rows together, so on and so forth, right? So what is the nice thing about this? Okay, when I say select volume from stocks, all my volume data are stored sequentially, right? So my disk has to go through where the volume information starts. And then all it has to do is just read through, and done, right? It doesn't have to skip any unwanted columns. Every single value it is reading sequentially is absolutely needed. So it's going to read through that, right? And it is done. It's going to be extremely fast. It's going to be extremely fast when you do select volume from stocks on a columnar structure as you see here now. Okay? Now to the other sad part, okay? Select third record from stocks. This is not going to be very efficient in a column store. Okay? Or when you say select star from stocks or select all the rows from stocks, it's not going to be very efficient because you have to go because understand, or remember, the column values are stored together. So you have to go like this. We're looking for the third record, right? So you have to skip the first column value, the second value, and the third value, and pick the third value because we want the third record. And that's just column 1. You have to do the same thing for column 2, same thing for column 3. Now you're doing skipping, right? So select the third record from stocks. It's not going to be that efficient in a column store. Okay? So now, boom. Let's compare side by side. Row store, column store. Row store or row major format, column store or column major format. Okay? So a row store is good for operations on entire rows. We saw that, right? Select star from stocks, the very first slide. And column store, good for column specific operations or aggregations, etc. Right? Column store is great with that. Row store is not so good for column specific operations and aggregations, whereas a column store is not so good for operations on entire rows. Okay, so now we have seen row major format and column major format. Both has advantages and disadvantages. The one more advantage with column store is the compression is going to be awesome with column store. Why? Because all the column values are stored together. All the column values from the same column are stored together, which means I have strings stored together, I have date values stored together, I have number values stored together. So I can apply compression based on the data type of the column. It's going to be very efficient, okay? And you can do a lot of encoding enhancements as well, like how you save the column on the disk, right? You can go to that level and save everything efficiently, right? So far we have seen, sorry, let me go 2 steps forward. So far we have seen what is row store, what is column store. We have seen the advantages and disadvantages of each, and both has advantages and disadvantages too. Let me stop here. Any questions, guys? I'm going to stop just a little bit for questions because I need to move forward soon, all right? Yeah, Deepak is asking, if we add a var filter, how this will behave? Or when a record is added, how this will behave? Yes, good questions, good questions. All right. How's columnar? Perfect. That's a very good question. I have answers for those. I have answers for those, yes. It is the same concept used in most NoSQL databases. True. Yes. So Meghana Rakesh is asking, is it the same concept used in NoSQL databases? Yes. Most NoSQL databases are columnar, and whenever we're talking about columnar formats, yes, this is what they use. And the other question is, if we add a var filter, then how will this behave? We're going to cover that today, actually. All right, perfect. So let's move forward. All right. Okay. Enter record columnar file or RC file. It is a combination of row store, a row major format, and a column major format. It's a combination of both. Okay, we want to get the best of both worlds, right? So we're going to combine both together. So that's what RC file is. It stands for record columnar file. So it takes the advantages of row store and advantages of column store and put together a file format. Now we are talking about Hadoop. Okay, we're not talking about SQL Server or Oracle or MySQL. We're talking about the big data space. An RC file is a file format in big data space. Okay, and it is one of the file formats. There are many such file formats, right? What is a file format? Good question. So, for example, the stocks data sets or the weather data set that you would have seen with the word count problem, whatever, those are text data, right? Those are textual representation of data. The RC file and the other format that we are going to see in a little bit, that is ARC or ORC, these are binary formats. Okay, so when you open the file, it's not in human readable format, but when you create these files, when you transform your text-based stock data sets into an RC file transforms your raw data into a row columnar store. It does it for you. Okay, we may not have the time to see how it does it, but it does it for you. All right. With these, it's very simple to convert actually. Take a text file and convert it into an RC file, or take a text file, convert it into an ARC file. It's very easy. Okay. So you don't have to worry about writing a program or anything. If you're using a tool like Pig or Hive, you can easily do it, right? But the point I wanted to say is these are specific file formats. When you open the file, it's not human readable because it's stored in binary. Right? And the program basically, the program, for example, if you're using Hive to create an RC file, it takes care of the translation from text to RC file for you, right? So you're not basically moving things around. That's what I'm trying to say, okay? Moving on. Okay, so here is the, here is how an RC file can be visualized, okay? So this is on the left. On the left, we have our stocks data set, our regular stocks data set in a row major format. That is, in an Excel format, right? A row and column, or row major format, right? RC file first divides the data horizontally, right? So within that horizontal, and it calls it partition. It partitions the data horizontally first, right? So that is the lengthy line that you see here. And then inside that chunk, inside that data chunk, it transforms the data into columnar. Okay? So the horizontal partitions are called row groups. So in this slide right here, on the left you have a row major format, on the right you have format in RC file. So the data is divided horizontally, right, into row groups. And then within each row group, the data is transformed from a row major format into a column major format, right? So that's what you see on the right, right? So first a horizontal partition, and then, a vertical partition, that is changing the data from a row store to a column store. So the RC file will look like what you see on the right, right? So what is a row group? Row group is nothing but your set of data from the horizontal partitions. So RC file will look at your data set. Every 4 MB, it divides the data into chunks, and it calls it row groups, right? And within that, it will change that data within the row group into columnar format, okay? So now if you want to do average volume, it's just very, very simple, right? You read the columns from each row group, just the volume column, right? Because you can read it sequentially, right? Because of the columnar benefit. You can read the volume column sequentially, just read it from each row group. You don't have to look at any other column. You're not skipping any columns here, right? You don't have to skip any columns here because volume is stored sequentially within each row group. So you start from row group 1, read all the volume, done. You go to row group 2, read all the volume, and do an average together, right? Okay. So now if I want to read the third record, that is not so bad now. right? Because the row group, the size of the row group is 4 MB. Okay, the size of the row group is 4 MB. Yes, you will do some skips, but it's still okay, right? Because it's a smaller size now. Imagine imagine we were talking about a 2 terabyte data set, right? And if you're familiar with Hadoop, when you upload this file to HDFS, and in a minute or two, I'm going to explain some concepts which may not be as familiar to you, which will be definitely new to you if you're new to Hadoop. Okay, so bear with me here. If you're uploading a file to HDFS, this 2 terabyte file is going to be split into blocks, right? So now in a columnar format, if you don't divide, if you don't do horizontal partition first, and if you store this entire 2 terabyte file into a columnar format, right, the volume column can be at the very last block, right? The volume column, the information for column volume will be at the very last block. So you have to pull the data from different nodes, from different blocks to construct one record. You don't have that problem here anymore, right? Because it is all stored together inside one row group. You don't have to go to another row group to construct a row, right? Because all the row information is in one row group, right? So that's the benefit of merging both row columnar, both the row major and column major into one chunk, right? Into one concept. Okay, because all your row information is in one row group. That's the beauty of this, right? Plus, it also gives you the benefit of doing average, column specific operation, aggregation, whatever, right? You go from one row group to another row group, you read the columns, you're done. I see some questions coming in, so let me look at them, okay? The row group is sorted. No, it is not sorted. You have to sort the data first if you want the row group to be sorted, so it is not sorted. Can one row belong to 2 different row groups? No, absolutely not. Okay, one row will always be in one row group. This concept will not give good compression. Actually, this concept definitely gives you good compression, because you will do compression at the column level. Columns are compressed, okay? Each column is compressed, by the way, all right? And RCFile is created by Facebook. Actually, I didn't mention that, right? RCFile is a joint collaboration between a Chinese university and also with Facebook, okay? And when RCFile went live, Facebook was the biggest user of RCFile. And they did several benchmark tests, and the compression was significantly better when compared to a regular text file, right? Because you can compress at the column level. And since the column values are grouped together and they are alike values, the data types are very similar, right? You will get good compression. Although, someone who asked that question has a good point. The file size is, the row group size is only 4 MB, so they might hit a compression. It may not be as efficient as compressing a big file, and that is true, okay? That is true. When we look at ARC, we'll talk more about that, okay? All right, let's move on. Okay, so someone asked about filtering. How does a where condition works here, right? That's an excellent question, and I'm going to answer that right now. Okay, the very first thing, no, not the very first thing, like a couple minutes back, I said each column is compressed, right? So assume I do a query like this. Select star from stocks where symbol equals, what is the symbol? RSC, right? Symbol RSC. Since the columns are compressed, you have to uncompress, even to execute this record, even to execute this query, you have to uncompress the column to send the result back to the user, okay? But this is what RCFile does. It doesn't uncompress or decompress all the columns. It just uncompress or decompress the second column, or the column that is needed. That is, in this case, the symbol column. So it will decompress the symbol column, okay? It will look whether the symbol column has RSC or not. If it has RSC, it will decompress the other columns. Okay, if it doesn't have RSC in the row group, it basically skips the row group. Okay, so it first decompresses the symbol column, just the symbol column, right? If it doesn't find the symbol value RSC, there is no point decompressing the other columns because they don't matter anymore, right? Why do you want to decompress a column when you're not interested in the value? Makes perfect sense, right? So it does decompress the symbol column on each row group. Next, row group 2, again, decompress the symbol column, right? Here, we see 2 records for RSC. Now, all other columns are decompressed. Makes sense, right? So this concept in RCFile is called lazy decompression. Okay, so this concept in RCFile is called lazy decompression. It gives you excellent benefit, right? So compression, we already saw compression, right? Since the column alike values with the same data type are stored together, you're going to get excellent compression, right? And you can do column-specific compression. And with lazy decompression, you know, your queries with predicates, especially queries like this with where condition, you know, like one of our participant asked, right? A query with a where condition like this, it's going to run great. That is, queries with predicates, it's going to be great. It's going to execute fine, okay? So now, perfect, all is good, but there are some inefficiencies with RCFile, right? Guys, if you're familiar with our Hadoop or big data space, you have tools coming out like every other week, okay? There are efficiencies being made to every single inefficiency out there. You know, that's the power of our open source community, any open source community. And Hadoop or big data being one of the fastest growing space, we have a lot of people contributing to, you know, to the platform or to the framework, right? So when RCFile came out, it was great. It was an excellent concept, but, you know, people saw inefficiencies in the concept, you know. The first inefficiency is there is no metadata about the columns. RCFile does not store, you know, metadata about the columns like your database would store, right? Take SQL Server, MySQL, any RDBMS, for instance, right? You're creating a table, you can add index to the table, you know, and the database to some extent knows about the values in the column, you know, so that it can cater or efficiently execute queries, whereas RCFile, no, it doesn't do that, right? All it did was basically did a horizontal partition and then do a vertical partition to do, you know, to combine the row major and the column major format together. So there was no metadata about the columns, which means, you know, with lazy compression, yes, you get some benefit. Yes, your queries are going to execute faster when you have predicates, but when you don't have a lot more information about the column, you know, you can't optimize much, okay? The next thing is smaller 4 MB row group. If you know about Hadoop, you know, and if you know very well about HDFS, your file, when you upload to HDFS, it's going to be broken into blocks. More specifically, 64 MB blocks. And that's a bigger block size, right? And if you don't know that concept, you know, join our Hadoop Starter Kit course, and we explain what is a block to great depth, okay? So, and we even explained why the block size is so huge in HDFS, like 64 MB or 128 or even 256 MB these days, right? But RCFile, the row group size is so small, it's only 4 MB, you know, meaning the sequential read is going to suffer when you do that. You know, when you have very small a block size or a row group size, you can do only so much sequential read, right? Sequential read is reading the disk sequentially. You know, bigger block size will give you better sequential reads, meaning faster performance, right? With 4 MB row group size, the sequential read is going to suffer. Next, less efficient compression. Again, it ties back to the first point that I mentioned, no metadata about the column. When you don't have a lot of metadata about the column, you cannot do much in terms of compression. You can do a lot with compression, just with, you know, knowing the type of the column, okay? But encoding, you cannot do efficient encoding when you don't know in depth about what the column is all about, okay? So less efficient compression. Now that's where R comes into play. Okay. Most people say ORC. I always say, it's not how it is called in the big data community. It is called ARC. So if you want to be cool when you're talking to big data people, say ARC, not ORC. Okay. And ARC is an effort from Hortonworks. It's an effort so it's a file format from Hortonworks, even though it is an open source. Hortonworks spent a lot of time and effort in building this file format, ARC. Okay. Well, in our course, we also have another file format called Parquet. Parquet it's a very similar file format to ORC, and it's a joint effort between Cloudera and Twitter. They're very similar, because they were built at the same time, and both companies, obviously, when they were building this, they did not share a lot of information between them. Okay. So ARC is from Hortonworks, Parquet is from Cloudera. We're not going to talk about Parquet today, but we will definitely touch on ARC because ARC is fascinating. I personally like ARC very much. Okay. So with ARC, again the same thing, right? ARC is another file format, just like RCFile. It's not a human readable format, meaning everything is binary. When you open the file, it's all bits and bytes. ARC stores a lot of information with the file. So when you transform a text data to ARC format, it takes the file and it basically does transformation. It adds like a file footer. It adds indexes to the file, right? It creates like indexes and stores the index along with the file. You will hear people saying index or statistics in ARC. Okay, they're interchangeably used. I've heard some people say are referred to them as indexes, or some people will refer to the same data as statistics. Okay, so what makes ARC special, and what is the difference between ARC and ORC? Sorry, ARC and RC, right? Very similar concept, guys. Okay, very similar concept. ARC stands for optimized RC file, right? So the O stands for optimized. So they've taken the entire RC file concept. Okay, so they've taken the entire RC file concept and they have made it better. Okay, so you still have the horizontal partition and then vertical partition. The same concept still applies. Okay, ARC does the same exact thing. It divides the data horizontally. In RCFile, you call it as row group. In ARC, you call it as stripes. Okay. In RCFile, your row group size is 4 MB, whereas in ARC, your stripe size is 64 MB and above. Okay, 64 MB and above. Why so high? Because you can take advantage of sequential reads. Okay, so you can take advantage of sequential reads. The beauty of ARC is not the stripes or the stripe size, although it definitely brings efficiency, right? It's the next concept that we are going to discuss, which is related to file level statistics. Okay. So ARC maintains few indexes or few statistics in few places at few levels. Okay. At the file footer, it stores a file level index and a stripe level index. Okay. I'll talk about the row level index in a bit, all right, when we talk about how the data is laid out in stripes. Okay, so the file footer has a file level index and stripe level index. So what is an index in Spark, in ARC? Index is nothing but statistics about columns. That's all there is, right? It stores min, max, and sum values for each column. That is it, okay? At the file level index, for each column, it has the min and the maximum statistics, min and the max value for each column. So if you look at this, let me zoom in a bit here, just to make it visible, right? So if you look at this, the file level index for symbol column, this file has the minimum value for symbol column is AB and the maximum value is OL. For closing, for the closing price column, the minimum value is 100, the maximum is 2200. For the volume column, the minimum value is 40,000 and the maximum volume is 200,000. That's for the file. Similarly, if the file has two stripes, the stripe level index will have the same level of statistics at the stripe level. Okay. So again, what is a stripe? Stripe is very similar to row group. It's the horizontal partition data, right? Stripe, that is exactly what that is. It is a bigger, think of it as a bigger row group, okay? It is a bigger row group, and the stripe level index will have the min and max statistics within that stripe, okay? So again, we have 3 columns. If we take 3 columns, we're just assuming 3 columns, and this statistics will be there for every single column, okay? So we are just, for the illustration, not to make the slide crowded, we are showing just 3 columns: symbol, closing, and volume, right? Minimum value for minimum and maximum for symbol, minimum and maximum for closing, minimum and maximum for volume, so on and so forth, okay, for all the stripes. And both stripe level index and file level index are at the file footer. They're at the file footer, okay? So now let's talk about stripes. Oops. We went a little bit farther. Give me 1 second. We went a lot far. Okay, we're back. So now within the stripe, I said a stripe is nothing but a bigger row group, right? So within the stripe, you again have index. For every 10,000 rows, you have an index, and this is called row level index, okay? So you first have index and then you have the data, right? So within stripe, let's say your stripe, now that your stripe is bigger, right? It's 64 MB and plus, right? You will have lot more rows within that stripe, okay? So let's say you have 30,000 rows. That's what, that's the illustration that we have here. So for every 10,000 records, you have row level index, same kind of statistics. For symbol column, you have min and max for the 10,000 rows, right? For closing, you have min and max for the 10,000 rows. For volume, you have min and max for the 10,000 rows. So on and so forth. For every 10,000 rows, you have min and max statistics for every single column. You have row level index first, and then you have the data for that stripe. Makes it easy, right? So now let's look at the power of ARC, okay? So now we run this query. Let me zoom in again. Okay, now let's run this query. Select star from table where volume greater than 130,000. Okay. The very first thing when you issue this query, I'm assuming you're issuing this query on an ARC file, maybe using Hive, okay? So you have, ARC will first look at the file level index. Do I even have records for volume greater than 130? It looks at the file level index for the column, for the volume levels, for the, excuse me, statistics for the volume column, right? So 130,000 is within the limits between 40,000 and 200,000, right? So ARC decides, yes, this file has the records. What if you write a query, select star from table where volume greater than 200,000, or let's say volume greater than 300,000, right? ARC will look at this file index. It will look at the volume statistics. It will see the max is 200,000. There is no point even reading this file, okay? And if your data set, let's say, is 2 terabytes, right? And if you're able to skip an entire file based on the statistics, that's quite powerful. You just didn't read the whole file at all because there is no need. From the file level index, we know this file doesn't have records over 200,000. There is absolutely no need to look for records for 300,000, volume greater than 300,000. It's not going to be there. You just skip the whole data set. You're done. Your query comes back in like a second. That's efficiency, right? So now let's go back to 130,000. We're selecting this table for volume greater than 130,000, right? So now 30,000 is between, the min and the max limit for volume by looking at the file index. Once that is done, it will look at the stripe level index. Okay. Does stripe 1 has volume greater than 130? No, because the max is 120 for stripe 1. So it will skip stripe 2 altogether. Now, another optimization, right? Again, if you have a 2 terabyte file, and let's say your stripe size is 128 MB or 64 MB, whatever, right? And if you are able to skip 64 MB or 128 MB of data without reading anything else inside the stripe, that's massive efficiency. Get it? Right? So now stripe 1 is completely skipped. Go to stripe 2. Stripe 2 has volume between 40,000 and 200,000. Yes, we have records that we're looking for in stripe 2. So you go to stripe 2. Stripe 2 is at the top here, right? You look at the row level index now. Again, you skip the row groups, that is the 10,000 rows, 10,000 batch of rows, if you don't have it, if you don't have the values, right? So just by looking at the row level index, you can skip the first 10,000 rows, right? Because it doesn't have volume greater than 130 because the max volume is 80,000. The second 10,000 has it because the max is 200,000, right? So you have to read just the second 10,000 rows from stripe 2, okay? You don't have to look at, again, the third 10,000 row group at all. You just can skip it, right? Because the max is 90,000. I'm sure you can appreciate the efficiency now, right? With all this file level index, stripe level index, row level index, you can basically dice the data and look for or start reading the data only when you know the data has it. And this is maximum efficiency, okay? All right. Now, so this is called predicate pushdown, right? So predicate is nothing but your where clause. And how does the predicate gets pushed down to the file until we have what we need? You know, we don't want to read something which we don't care about, okay? All right. So you know how efficient ARC can be. So this is execution level efficiency, right? Compression. ARC is also much better in compression. Look at this, right? So this is a file, or this is a comparison from a screenshot or a picture from Hortonworks website, from one of their blog posts, okay? So a text file is 585 GB, and an RC file is 505 because it is compressed. Again, you have another format, Parquet, which I spoke about. It's 221. And finally, ARC, which is 131 GB. 78% smaller, guys. 78% smaller when compared to your text data. And even in a big data environments, when you have like, big, huge files, you have a big, huge cluster, you still don't have infinite space in your cluster. Space is limited. Space is still scarce, although not as scarce as before, but it is still scarce, right? You need to conserve it. So ARC from the compression standpoint, it's 78% smaller. How, right? Because, yes, ARC does very similar compression techniques to RCFile, but it encodes the data. Now it knows it has more information about the columns. It can encode the column very well. It does more encoding. It looks at string value and it encodes differently. Encoding is how you basically store the information on the disk, okay, in bits and bytes, right? How do you encode and store it, and how do you read it back and present it to the user? So when you know more about the columns, you can encode it better, right? You can apply efficient encoding. We talk about encoding in a little bit more detail in the course. I don't think we have time now. We're already hitting the 1 hour mark. All right. So that is ARC. Okay. So to summarize, we first saw how ARC is different than RCFile in terms of storing the file. Next, we saw how ARC gets its efficiency, execution level efficiency. And next, we saw with encoding and compression, ARC does much more compression, right? So in this hour, we have seen row major, ARC, RCFile. That's a lot of information to process, right? First we saw what is row major, what is columnar. We compare the differences, the advantages and disadvantages between both. Then we look at RCFile, how it is better. Then we saw how ARC is better than RCFile, okay? We looked at predicate pushdown on both RCFile and ARC, okay? So now, let me look at your questions. I know some of you guys have been chatting and asking questions. Let me look at your questions. All right. How the replication take place? Okay, let me scroll up a little bit so that I can I can look at some more questions here. Can you store data in Hive tables? Bashir is asking, can you store data in Hive tables? Can you take advantage of Arc? Absolutely. You know, RCFile, when Facebook came out with RCFile, Facebook was the biggest user of Hive, okay? And they created RCFile to work excellently with Hive, okay? When they did ORC, they made sure Hive is the first target because the Hive community is big, guys, right? Because everyone knows how to write SQL. For those who doesn't know about Hive, if you're a SQL developer, think like you're writing SQL on Hadoop. That's what Hive is, okay? And absolutely, Hive can take advantage of, it can take advantage of RCFile, it can take advantage of Arc, it can take advantage of Parquet, okay? So absolutely can. Meghana Rakesh is asking, does it mean that it is compulsory for in the projects to store in any one of the format? It is not compulsory at all, right? You can absolutely store in text format, but give it some thought, okay? You know, if you're storing a 2 terabyte file and if your things are running slow and converting to ARC or RC file is super simple, you know, with tools like Hive, it literally takes like 2 minutes to convert these things, right, to another file format. So why won't you use it? I think that's the question, you know. It is definitely a good thing to look into, okay? So it's not compulsory, but my question is, why won't you, right? Okay. How the replication takes place, same thing. It's again another file, okay? It's again another file. It's going to be broken down into blocks when you upload it to HDFS. Again, a hard limit. If your block size is 64 MB or 128 MB, it's going to be broken out and it's going to be put into across your data nodes. Very simple, right? If you store, can you access data using Impala? Okay, so Impala is a tool from Cloudera. Arc is something from Hortonworks, right? You can find like you can work with Impala and Arc, although don't expect too much because these are competing technologies from competing companies. Okay. I didn't get how ARC file is compressed at the columnar level. Very simple. You can specify the compression codec. You know, if you want to use Snappy or gzip or whatever compression codec you like, you can say this is the compression codec I want to use on my columns, and each column is compressed individually. That's the difference, right? So if you compress a table, and for example, Oracle, you're compressing your table can be compressed as a whole. Whereas in Arc or file formats like RCFile and Arc, each column is compressed separately. And this gives you better compression because since you're compressing each individual column, you can take the benefits of the like values stored together. Okay. Yeah, good question. When we have Arc file, which is better than RC, why we need Parquet file format? Great question. Everyone asks that, right? I mean, from the community, we all have the same questions. Why we have so many file formats? The straight answer is, to be honest, the Arc is from Hortonworks, Parquet is from Cloudera, and both are competitors, right? So when one came up with a file format, the other one has to do something about it. And they claimed they were both working on the same file format at the same time, and there was no big transparency between both of them. We don't know how true it is, but that's what they say, okay? Cloudera, interesting story is Parquet. Parquet was a joint effort between Cloudera and Twitter. Why would Twitter involve with Parquet? Because Twitter has hierarchical data that they have to store. You know, so if you look at tweets, if you're familiar, if you're a student of Hadoop developer in real world, you know, we have a project where we pull the data from Twitter and we show the Twitter messages, right, as in JSON format. They're hierarchical, very nested, not hierarchical, very complex nested data structures, right? And they want a file format which can handle that better. That's the only reason Twitter invested in Parquet, because Arc is not so great with complex nested format, right? To, you know, if someone is really struggling to choose between Arc and Parquet, I would say, you know, go with the distribution. If you're using Hortonworks, go with Arc, you'll get better support. And if you're using Cloudera, go with Parquet. If you're using nested structures, definitely go with Parquet because Parquet is going to be superior on that. Write operation is costly. You have to think, someone also asked me, well, how about append operation? How does it work, right? Hadoop is not a great tool for you if you want to append data. Okay, if you want to append data to your existing file, it supports appending data to your existing file. The first version of Hadoop did not support appending to the file, but the later versions did. But if you're looking at appending file, it's not a great solution. Although I have to say, you can append file to ARC, but most likely you'll be creating new files. You won't bother with the existing files. Okay, Hadoop is a batch system, right? So you will create new files in that case. Oh, there are a lot of questions here. Okay, I'm going to take like Hive, Pig, what else? Okay, so I'm going to go to the lab. We've answered quite a bit of ARC and RC question. I think this question is from someone who is very new to the technology, I think, so I'm going to answer that. Hive and Pig, what else? So I mentioned two tools, Hive and Pig, what else? There are so many tools. There are so many tools, but these are all interesting tools, okay? They each make the life of the developer or someone working in Hadoop a little bit better. So Hive, you can write queries. Pig, you can write scripts. You don't need to know a programming aspect of it, okay? You don't have to be a programmer to work with Hadoop, and that's why these tools are in place. Some other tools are, you have Scoop to bring the data from a database like Oracle or SQL Server into Hadoop. You have Flume if you want to move like log-related information. You have streaming applications or tools like Kafka. And the more upcoming technology or framework is Spark, which is Spark's main objective is to replace the MapReduce component of Hadoop. Spark and Hadoop can work together as well. Again, if you're very new to Hadoop or even Spark, look at Hadoop Starter Kits and Spark Starter Kit, and both are absolutely free. Okay, guys, we're running out of time. I'm going to move forward with the presentation because I said we have an offer for you guys. So I'm going to cover that. Okay, so so you learned an somewhat a complex topic, RCFile and ARC today, right? I mean, if you're learning by yourself, you will be, I wouldn't say lost, you will eventually get it, but it's going to take time, right? Whatever we saw in 1 hour, you have to spend like a lot of hours to grasp this concept, okay? So it's going to take some time. And, when we decided to do a webinar and we were trying to think of a topic, we said, okay, we'll do RCFile and ARC because we just came out with an update to our course, and it'll be a nice thing to do. But the challenging thing is, how do you fit everything in an hour, right? And I think one of our strengths is basically we can take complex topic and we can deconstruct it to a level that you can teach complex topic easily, or you can make the students who are on the other side can understand you, can make sense of the concept, makes it easier for them to grasp the concepts, okay? So now think about this. If you're new to Hadoop, you learned a lot today, right? You learned a lot. And, I'm going to, you learned a lot, even a complicated stuff, right? When presented correctly, things are not as complicated as you would think. But if you set out to do if you set out to read things on your own, it might take time. Eventually you will get it. It might take time. Most often than not, we see people get excited about Hadoop, get excited about big data technologies because they see some of their colleagues moving on to another job as a big data developer or engineer, or they can see some of their friends moving into big data, making a little bit more than they are, than you are making, right? So we see that a lot. People get excited about the technology. They want to learn. They look at this word count problem. That's the very first program that you encounter, and that is in Java. People get like, okay, what is this, right? I don't get it. What is HDFS? How they all work together? Most often than not, they get very excited to learn Hadoop, and then the excitement basically like dissipates because the concept is just so hard, right? And we often hear people, Asking questions, I see programming used in Hadoop. Do I have to be a programmer? That's one of the questions that most often gets, But just taking a step back, things doesn't have to be this complicated, right? I mean, the technology is a vast set of technologies, but it doesn't have to be this complicated, right? So for those who would say, I'm not a programmer or developer, is Hadoop right for me? We have to say, we have students from different streams on the technical side, right? And also on the non-technical side. We have Java developers, we have SQL developers, we have Unix engineers, we have system admins, we have business analysts learning Hadoop. We have QA, learning Hadoop. So, so don't think if I have to be a programmer or I have to be a developer. I have to be technical to do Hadoop. Someone just asked, there are so many tools, right? What are these tools for? These tools are there, like Pig and Hive and Scoop. They are there to help even if you don't know an ounce of programming. If you're a SQL developer, all you need to know is SQL, and SQL is easy, right? Select star from tables. You know how to write joins. You can work with Hive. You don't need to know Java programming, okay? So you don't need to know that to learn Hadoop, okay? And things don't have to be complex. Don't get disappointed if you're trying to read by yourself and you don't get it. Give it some time. We are here to help. Take one of our courses, Hadoop Starter Kit or Spark Starter Kit to start with. If you want to know the basics, it's free. So go with it, right? So next, what are our courses? We want to answer some frequently asked questions, right? The first thing that they ask is like, do you have a training center somewhere? Is it an instructor-led training? No, we do. All our courses are step-by-step, well-organized, well-formulated video-based lessons, right? Again, things don't have to be complicated, right? You learned a lot of concepts in an hour. So when courses are well-structured, when content is put together nicely, you will have no problem grasping the concept. That's where most people fail because, when courses are not structured properly, even when you have like a classroom instructor, if he's not structured properly and if he's reading you from a book, even an instructor-led training is not going to help you. Okay, so it has to be well structured, well thought out. We take our time to put these things together. The next frequently asked question that we get is, how do I practice it? How do I practice Hadoop? Because you said Hadoop is this technology with multiple computers working together. I don't have multiple computers. Do I need to have a bigger laptop and all that? No. We got you covered. We want to make things easy for our students because a lot of time we see like people, they get the concept, right? But they want to try it out. But where they would try it out? They try to download this clunky virtual image. You need at least like 8 GB to run a decent virtual image to work with it. 8 GB in your laptop, and most of you may not have it. You may or may not have it. But we want to keep easy for our students. So anytime you enroll, even in our free courses, we give you access to our cluster, right? It's a 3-node cluster on AWS, shared by thousands of students just like you guys. And you can try out MapReduce programs, Hive, Pig, Scoop, and all that. One thing you won't be able to do is restart, uninstall, installing services and things like that because it is a shared cluster, and we don't want any disruption to the cluster. The next question that we have is lifetime. How long will I have access to the course? You will get lifetime access to the course. Very simple. Hadoop, the next question we get is Hadoop is a growing technology. Of course, we know that. How often do you update the course? We do regular updates on our courses. Okay. So just last month, as I said, we came out with RCFile, Parquet, and ARC. And today, as a matter of fact, today we'll push an update to our Hadoop Administrator in Real World course on the topic of troubleshooting. So you'll have like 4 new lessons on that chapter today. So we do update the course regularly, and you can see what we're working on now if you go to hadoopinrealworld.com/upcoming-releases. Okay. So the next question that some of us ask, and believe me, they ask us this: how are we different from others? How how is Hadoop in real world different from others? We have a simple answer for that. We would like to say our free courses are better than others' paid courses. Period. That's it, guys. So you take our free courses and you compare that with others' paid courses, you will see our free courses are better. All right. So there's no comparison there. And most of our students who have taken our free courses can attest to that, right? And we say that with pride and confidence. We don't have any problem saying that, and because we strongly believe in that, and we work harder to push our courses better. Okay. All right. Any other questions, guys? I have a few more minutes for questions. If you have any questions. Yeah, some people are leaving. Bye, guys. Thank you. Thanks for joining. Someone asked me about a Spark course. We do have a Spark course. It's called Spark Starter Kit. It's a beginner course. It is a beginner's course also, although we cover a lot more than other fully courses. The full Spark course will be ready next year. We are still putting together the content. If you know us, we don't put out courses like willy-nilly. We take our time. So we do take our time. Are the courses interactive on chat or just video recordings? So you have a Q&A section on our courses, so you can ask questions and we will answer. One thing I have to say about the Q&A, we give descriptive answers. We don't tell you, oh, first Google and then come to us. No, you have a question, you ask us right away. Don't hesitate, okay? So we want our students to engage with us right away when they have problem, and you don't have to Google it before you come to us or anything like that. You just post the question and we'll do the answer. My name is Patrick. Someone was asking for my name. What is the scope and the future as Hadoop administrator? I mean, okay, so most of the companies, mainstream companies, are moving into Hadoop, meaning you would need people to manage a Hadoop cluster. So your day-to-day responsibilities would be to maintain the cluster, of course. You would be adding nodes, removing nodes to the cluster. You would be balancing the cluster. You have to troubleshoot when there are issues. There could be slow-running jobs that are getting killed. Developers will come to you for that. And there could be accidents too, data could be deleted or corrupted. You need to know how to handle that. Or, key services like name node or resource manager can go down. You need to know how to recover that. So those things. Okay. Something new. Thank you, Madhu. Madhu says, thanks, Patrick. As usual, it's always something new to take back from your presentations or classes. Perfect. Thank you. All right. Duration of the course. Our courses are like 15 hours and plus, I would have to say. We do update our courses regularly, so I might give the old number. But I think our developer course is close to like 16, 17 hours at this point. And our administrator courses is a little over 10 hours, I believe. I could be wrong on that, actually. How long the cluster access is available? The cluster access, again, is lifetime because you have lifetime access for the courses. The cluster access will also be lifetime. The Spark course cost, we don't have a Spark course yet, so I can't give you the cost because we don't have a fully paid Spark course yet. We have a Spark Starter Kit course, but that is free. You can enroll it like right away. And how do you enroll? You just go to courses.hadoopinrealworld.com and you can enroll to the course right away. Okay? All right. Guys, thank you so much for joining. I always have a blast when I come online and do a live session like this. We get to meet people, we get to talk to our students. We always love that. So guys, thank you so much. All right. Okay, guys, thank you. If you have any more questions, feel free to send us an email, info@hadoopinrealworld.com. Okay? Thank you, guys, and see you next time.